Hello everyone, in today's video we're going to be taking a look at Numpy. I'm going to say Numpy about 100 times because that's what I always thought it was. But Numpy is a really slick import that's going to give us the ability to actually do a lot of mathematical computations with arrays. Now, for those of you who grew up when I grew up with programming, all we had was arrays. This newfangled list stuff is all fancy nonsense. But basically what it does is it gives us an object that's going to be all nice and fixed in size. It's going to fix quantities, and it makes it really easy to do large mathematical operations too. So let's do it. So the first thing we're going to do here is we're going to go ahead and import NumPy here. Now, the simplest way that everybody does it is they simply type in import NumPy. See, you want to say Numpy. You know you want to say it as NP. Now, if I come up here and press the run button, you'll see nothing happens. All it's done is reached out and grabbed us a copy of that lovely library and has brought it to us, a module depending on import. Depends on what generation of program you are. It all means the same thing. So what we're going to do now is demonstrate what these arrays look like and kind of how we sort of fiddle with them. So I'm going to go ahead and create myself a couple lists here. And I'll keep it kind of really simple here. We'll do 1, 2, 3, 4 in my first list. And for list 2, we'll go ahead and, lists. I don't know about you, but like once I got used to tuples, like I don't do lists anymore. It's weird, hard to explain. So what we need to do now is we need to convert these lists of numbers into a Numpy array. I did it, told you. Don't worry, it's the same thing when I say it. So one of the cool things we have here is we have to actually use this special command. So to do this, I'm going to keep it nice and simple. We'll call it array1, and I'm just going to use np dot array, which basically is expecting us to feed some kind of value into it. You can see it takes quite a few. We're going to feed list1 into it. I'm going to say array2 equals np dot array, and I'm just going to convert list2 into an array as well. Now, the weird thing here is if I print this array1, let's go ahead and let that run real fast. You'll see that it gives us, looks a little bit like a list. What you're going to notice about our lovely list here is the fact that we don't have any of these lovely little commas here. This is not a list. This is an array. Remember, it's a fixed length item. It is an immutable item. It's got all sorts of fun little stuff in here. Now, let me start to show you where people have a lot of fun with these arrays to make your life a little bit simpler. So one of the cool things we can do with arrays is we can actually add arrays together. So if I wanted to, I could say array3 equals array1 plus array2. Now, if I were to come down here real quickly here, and I'll just go ahead and print array3, and I'll let this one run, what you'll observe is it will go ahead and add the values of the two lists together inside of it and return the array that contains. So as you'll see, you're expecting to have 1, 2, 3, 4, 5, 6, 7, 8. Instead of doing that, it took the two arrays and added the individual values together. So you can see here that 6, 5 plus 1, 2 plus 6, 8. My 10 is 3 plus 7. Of course, my 12 is my 4 plus 8. Instead of combining the two ones together. Now you're sitting there going, oh, that's new. I've never seen that before. That's kind of funky. I mean, can you go hard on that? Yeah, you can go real hard on that. Let me show you what I mean. Let's create another array. We'll create array 4. And what I'm going to do this time is I'm going to take array 1 times 5. Now, if I print array 4, if I were to run this one real quickly, you will see here that I took every single value inside of that array and I multiplied them by 5, and I created myself a new array based on those particular elements. Now, you're sitting there going, oh, okay, that's actually really helpful. That's actually more useful than a list, because if you multiply a list by 5, obviously you're going to get 5 versions of the exact same list, basically in a repeating order. Just don't try to multiply a set by 5. That would be scandalous. Now you're sitting here going, okay, this isn't bad. I'm kind of getting the feel for this. I like what you're doing. I like the cut of your jib kind of a thing like that. That isn't a bad system. Can we go a little bit harder on that? And the answer is, yeah, we can actually go a lot harder on this. So I'm going to go ahead and create a two-dimensional array. So I'm going to create array 5. And prepare for your eyeballs to hurt a little bit on this one. So I'm going to type in np.array, just like that, left parenthesis. All right, ready for some pain? Double left bracket, 1, 2, 3. And we'll go ahead and come to the end of this one, comma, and we'll do 4, 5, 6. So as you can see here, I actually have a two-dimensional list. And I'm converting it into an array. Now, if I were to come over here to print my array 5 here and go ahead and run this one real quickly, you'll see we get something that looks a little bit like this. And you're sitting there going, well, that's Interesting. So you have two dimensions here? And the answer is yes. Oh, we do have two dimensions here. We have our 1, 2, 3, 4. If you want to think about it in one axis, and of course we have the values here. Now, because we have a multi-dimensional array, we still have access to all the functions we've done up above. So for example, I can say array 5. You want to see something really scandalous? Times equals 2. Oh my goodness. That is like extra, extra scandalous there. Now, if I run this, you'll observe that every value in my two-dimensional array has now been doubled. Again, you can start to see why these are so darn useful. I'm actually going to clear that out for that purpose. But one of the cool things we have here is we actually have built-in tools to help us identify information about the actual array that we're dealing with here. We have something called shape, and we have something called size. Now, a shape is going to be a tuple of the lengths of each array's dimensions. You're saying, what? Let me show you. So let's go ahead and grab ourselves array 5. And what we're going to do is we're going to get the shape of that array. So I'm going to say array5.shape. Now, the cool thing here is that you'll notice it doesn't want a parenthesis. Now, if I run this, you will see it returns a tuple. Now, this tuple tells me two things. It's going to tell me I have two different components here, and it's going to tell me each one of those has 3 total items in it. Now, not to confuse you, but if I came over here and did array5.size, instead of getting a tuple that's going to tell us basically how many different dimensions we have, plus how many elements are in each dimension, it's instead going to be telling us the total number of elements inside of our item. Now, very, very sharp-eyed viewers immediately sit here and go, wait a minute, couldn't you use shape and take the values out of the tuple and multiply them together? In which case I say shame, just use the size command. It's vastly more clear as far as what you're trying to achieve. Now, things start to get a little complicated with our lovely little dimensions here. Because we have the ability to work in multiple dimensional arrays, we also get all sorts of fun array functions. We get all sorts of neat things where, for example, we can fill arrays with specific values if we wanted to do that. Now, the reason I really, really enjoy this is that it's going to give us the ability to do that. So, for example, let's say I want to say array 6 here, and I'm going to go ahead and fill this array with something here. Equals np.full. Now, the cool thing here is I can, of course, define all sorts of details. I'm going to define a 3x3 array, and I'm going to fill it up with the number 64, because 64 is awesome. Now, if I come over here and print array 6, so we've got a couple of these going here. Check this out. You can see my lovely 3x3 array here, and of course, you can see the fact that they're all set to a value of 64. Now, this is where things are going to start getting a little challenging. You're going to be sitting here going, okay, I get it. I get it. It's not too bad. Basically, you're getting silly. You're making lists that go in every directions and make me cross-eyed, and that's pretty cool. But is there a catch? I mean, like, this is all good stuff. Yeah, there is a catch. Let me show you. So let's go ahead and create myself another array here. I'm going to do a 2x2. Actually, we need to be more specific than that. We'll be evil here. We'll do a 2 here. Actually, I believe they expect a tuple. So we'll do 2x1, and then, of course, we'll fix it with the value 2. Oh, boy. Oh, boy. You can see what I'm about to do here. So what I'm going to try to do is I'm going to try to add those two arrays together. So I'm going to simply say array 6 plus equals array 7. Now, when I run this code, what's going to happen is you're going to have a heart attack. And the reason being is because of the fact that these two arrays are not the same shape. So because they're not the same shape, you don't have the ability to add them together. Now remember, with lists, we don't care. We basically get a longer list here. But with an array, once you start doing mathematical operations, you really have to take your time and make sure that the shapes of the arrays actually make sense for what you're trying to do there. Now, another thing that you find very interesting about these arrays, I will go ahead and cancel this out because this is all scandalous here. I'll just hashtag it out so it doesn't blow up on us anymore, is we can actually sort arrays too, which is a really, really cool thing. So for example, if I wanted to take my array, we need something that's got numbers in it. Array 5, yeah, we'll take array 5. If you keep typing in the word array, it stops looking like it's spelled correctly. We can actually come in here and we can sort it. So I can come in here and say array 5 dot sort. And the cool thing with sort here is you'll notice this gets really, really challenging because now you need to think about what axis you're sorting by. So for example, if I sorted by my 0 axis, let's go ahead and do array 5 again over here, run that one. You'll notice it's going to throw me a big angry none. That makes perfect sense. Now, the reason for that, of course, is because we're trying to make the value of the array an array that's been sorted. That's not how sorting works here. Instead, what we're going to do is we're simply going to delete this and leave array 5 sort like that. Now, if I run it like that, you'll notice that it's done a nice job of basically creating it. Now, the cool thing here is you can come in here, as I was showing you a minute ago, and actually change the axis that you're sorting with. So, if I switch to a different axis, unfortunately, my values are just so clean, you're not going to see an immediate change there. But we can actually define what dimension we actually want to sort by. In order to fix this, of course, we have to come up here and do like 3, 2, 1 or something like that. And now, of course, if I ran it again, you'll see my 3, 2, 1. If I switch it to the other one, or even better, I can actually limit it like that. We actually can recreate that and then sort it by that axis, making it a little bit nicer for us to go ahead and see what we're working with. The last thing we can do, and again, there's many, 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 many more things you can do with NumPy here. This is probably the one you're going to use a few times, is we actually have the ability to delete axes from it. Now, let's go ahead and generate array 8 here. I feel this is so scandalous. So we'll use the delete command this time. Now, delete is kind of frustrating because you have to feed in the array you want to damage. So in this case, which array should we pick on here? We'll pick on array 6, why not, comma. And then what it's going to ask us to do is it's going to define what exactly we want to do. If axis 1, again, are we deleting a row? Or are we deleting a column kind of a thing? So for me, I'm going to go ahead and do a 1 here. Axis equals 0. Now watch what happens when we print array 8 here. Go ahead and I'll let this one run there. You'll see, of course, you've eliminated that one component. Now, if I come over here and run this one like this, you'll see that it keeps it basically the same. Remember how we used to have 3 dimensions and now we only have 2? And that gives you an idea of how effectively you can kind of rush in here and do things. Now, that is a very, very fast turbo version of what you can do with NumPy. The biggest thing for me with NumPy is stuff like this. I find it fantastically useful if you have a bunch of items and you basically want to quickly do maths on big matrices or you want to do dot products and stuff. That is where NumPy is fantastic. Also, if you're doing something with a huge list, let's say you're working with images, this is just a great way to get in there and kind of fiddle with different components of the image without having to do a lot of kind of juggling in the air of all sorts of lists. Enjoy.